Okay, let's see. Okay, after midterm, okay, we move on our topic, okay? This is the 10, I think that is the this is the 10th week of our course, okay? We will move to next topic, which is deep learning basics. But before we move to next topic, I would like to still talk about something about network analysis, okay? At the end of our previous topic, which is T12, okay, we have a very specific topic which is not covered yet, which is called Netflow. Okay, so let's take a look at this one. Okay. Okay. If you go to Kaggle, okay, there are certain network flow, network packet, they are set. Okay, this one is called IP network traffic flow label with 75 applications. Let's just take a look at the data it provides. Okay, so you can simply just click the detail. Okay, it's right here. Okay, so it describe, okay, what the information, what the data, okay, it provide. Okay, there are several columns. Okay, so you can scroll right here. Okay, the first one is called flow ID. Okay, you can see it right here. It's a flow ID. Okay, so when we want to examine or we want to check whether our network has been attacked or not. Okay, usually we have two different ways. One of the ways is you set up the monitor, okay, which is a packet capture, as we talked about, a packet capture monitor to capture all the packet flow in or flow out of your network. Okay, usually you set up such kind of device at your gateway router. Okay, so that you can inspect all the inbound or outbound packet traffic. However, if you do so, the size of the packet will be very, very large, so that it is very difficult for us to analyze all those packets. And sometimes it is a little bit meaningless when you try to detect each packet, because sometimes, okay, among all the communication when an attacker wants to attack your network, okay, the attacker may try to establish several connections. Okay, from this computer or to your servers. So sometimes to use packet as a basic unit to do detection is a little bit meaningless. So sometimes we like to detect if there's we like to ask, okay, there are several connections, okay, among your device and attacker's computer, okay, which connection is malicious, which connection is benign. So that can effectively decrease the amount of data you analyze, okay, because we know for example, in a TCP session, okay, which is a connection, okay, it can has several packets. So we have a lot of evidence to help you to make a decision, okay, whether this TCP connection, okay, which is a TCP session, which is a connection, is malicious or not. So sometimes, okay, for a very large network like a campus network or industry network, okay, we don't capture each packet because we need a lot of storage and we need a lot of computation to analyze each packet, which is not that efficient. So sometimes we ask the gateway router, okay, to output this table, which is Netflow, okay. So most of the routers, Cisco routers, Jupyter routers, they can output Netflow data, okay. For each flow, okay, let's take a look at this one, okay. For each flow, okay, it has an identifier, okay. So for example, right here, for example, in this database, okay, it has 1.5 million flows has been recorded by the gateway routers, okay, and here's the records, okay. So it says, okay, the flow ID is like the following one, 172.19 to blah blah blah. It's just an index to help you to identify each flow, okay. So next one, okay, this more the next one is source IP, which means, okay, this flow is created by certain IP, right? So for example, the first one is 172.19.1.64. Okay, usually when you monitor your campus network, okay, that is the first IP, okay, that the first IP, the first packet and its source IP will be written here. Okay, this source IP. And next one is, and we see that in this data set, okay, 8% of the flow comes from 10.200.7.218, okay, which we don't know, but 8% of that and 8% of the flows comes from this IP. Okay, the next one is the source port. Okay, usually, okay, since you have learned common networks, okay, usually source port is not that important because it may be, okay, sometimes it is a random port, okay. And the other next column is destination IP, okay, which is destination IP and destination port and the protocol. The protocol right here is not application layer protocol. It is the data field in the IP layer, which indicates, okay, and the transport layer protocol is TCP 6 or UDP 17, or it is an ICMP packet, which is 1. Okay, so generally it is either 6, 17, or 1. Okay, so we can see that most of the flow captured here is a TCP traffic. Okay, the next one is timestamp. Okay, usually it is the time of the first packet. Okay, so you can know when the packet comes in or out to your network. Okay, flow duration. Okay, that is the first the duration of the first packet and the next packet, and the total duration of the flow. Okay, so we can see that usually it is in seconds. So we can see that, okay, we have the first flow, okay, it stands, that's for, okay, 45,523 seconds, and it is a very long communication, right? And usually it's not that, usually, okay, we don't do such kind of long communication between, normally, okay, because when you access a website, okay, or you read your email, the communication should be, I think less than few seconds. Okay, so 45,000 seconds is quite long. Okay, and the total forward packet, total backward packet means how many packets? Okay, in the forward direction. The forward direction means from source IP to destination IP. Okay, so the backward packet means from destination IP to source IP. Okay, there are another 87 columns right here. Okay, so you can simply just click this one and see all the following fields. Okay, so there are some other things I think is important for us to analyze security data. Okay, so we'll try to go over this list. Okay, the next one is the total length of forward packet. It means how many bytes has been sent from the source IP to destination IP. Mostly, okay, some attackers, they will try to send a lot of data packet to your server, try to crash your server. So this number might be useful when you try to distinguish normal flows or normal flows and malicious flows. However, I think after 2010, okay, lots of hackers, okay, they're aware, okay, they should not send such big amount of traffic to your victim, to the device you would like to attack. So this data, okay, the total length of the forward packet might be look normal. Okay, they only send a very few bytes or only a very few packet and try to compromise your device, your server. Okay, so but still this field is still important. Okay, because some of the attackers still send a lot of packet to your subnet. Okay, so that is the forward packet length of forward backward packet, and that's the maxima and minima and average standard deviation. So there will be a lot of statistic data, okay, about how big the packet size is. Okay, so just skip it. Okay, here's the bytes. Okay, and there are some other informations. Okay, we will skip right here. Okay, usually, okay, when you see ITAPSH or URG, something like that, that means there are certain data headers, okay, in the IP headers or TCP headers. They record, okay, the communication status between the source and destination. Okay, so for example, I believe you know what is TCP three-way handshaking, right? So when we do three-way handshaking, we will send a lot of control bits like C, ACK, right? RST, which means reset, urgent bit, okay, but we don't use it. Usually we don't use it, okay, and FIN, ACK, something like that. So your gateway router, when you ask your gateway router to record all the flow information, the gateway router, when they create those entries, those flow table entries, okay, they will, those routers will help you to record what kind of control bit has been sent between the source IP and destination IP. So if the for example, if the push flag, okay, which is in TCP header, has been checked, that means at least one of the packet in this flow, okay, and this flow has been set, okay, at least one of. So if this flag has been checked, we don't know how many push packet has been sent. We only know push flag has been set at least once. Okay, but we don't know how many times because it only says, yes, I have seen flag, a push flag has been set. Okay, so be aware of this definition. Okay, so including the header length, forward header length, backward header length. Okay, sometimes, okay, usually we say TCP header has 20 bytes, IP header has 20 bytes, and so on and so forth. Okay, but sometimes, okay, some attacker may use optional headers to compromise your system. So sometimes it is important. Okay, forward packet, backward packet. How many packet has been sent from between source IP and destination IP? Okay, minimum length, maximum length, average variance. Okay, how many counts? Okay, that is the other one. Okay, count means how many has been sent. Okay, this is a little bit different from the previous one I told you. Okay, that is the count. So send, reset, push, urgent, act, blah blah blah. Those are TCP headers. Okay. Up-down ratio means the ratio of how many data has been upload and download, which means forward and backward. Okay. Average packet size. There a segment means a TCP segment size. Okay. Header length. Okay. Average. How many payload, which means how many layer 7 message has been sent, or average, something like that. The baud rate means sometimes in this time period, okay, in this duration, okay, several packets has been sent, but they sent one by one, or they sent very short period of time. So we have a baud rate right here. So we have a number of things right here. Okay, I think it is good and that is good enough. Active and idle means how many seconds? Okay, this flow has been idle. Okay, so like this. Okay, the last one is label. Okay, label means this label is created by the dataset. It's not in the data flow. Okay, we have to label which flow is malicious or which flow is benign. Okay? There are several protocols. Okay, usually flow data does not they do not preserve this information. So for example, you can use workshop. Okay, we demonstrated before. You can use workshop to analyze those flows, those packets to decide, to identify which there's seven protocol. For example, FTP, SMTP, FTP, and blah blah blah. Okay, so the protocol and its name. Okay, so sometimes we can like this. We can take a look at it like this. Okay, there's some protocol is a number. Okay, which port number and use. The next one is the hook name. Okay, which is for example HTTP proxy. HTTP preproxy, something like that. That is the protocol used by your by those flows. Okay, so usually, okay, when we analyze a very big network, we don't analyze we don't analyze packet per se. Rather, we use the flow data. However, by using those flow data, we miss some information. For example, when we drop all the layer 7 message payload, so that we cannot expect what exactly layer 7 message has been sent from node 2 to the attacker. Okay, We only preserve all those header information. Okay, you can say that only header information. But there are a lot of research. Okay, they said okay, we can use those header information to detect whether attack has been deployed to your network. So make sure you. So we have a lot of tests right here, but you can see that okay, there are several examples that using this specific data set. Okay, for example, maybe you can see the label, which is good, which is much. You can see the labels. Okay, you can see that one of the I think the simplest one is to detect the label. It says benign, right? I think there should be some other data set which is labeled as malicious. So you can create a classifier by using the algorithm you learned, and to distinguish benign flows and malicious flows. Okay, I think that's good enough. Okay, and of course, in this website cargo, there are even more. For example, this one, label network traffic flows. There are even more data set. Okay, Netflow data set. Okay, like this one. Okay, that is basically the data field is almost the same. Okay, here's the index, number of source IP address, port number, and so on and so forth. Okay, so this one is more even reachable. Okay, it says what is the category? For example, this one. Okay, it has a category, right? The value is web or network or some other categories. You can even create a classifier, okay, and learn the data, then the flow data right here, and to distinguish different category of flows. Okay, for example, you can create a classifier at your router, and you can roughly, okay, I say roughly, okay, you can roughly, okay, say, okay, this flow seems like a little bit malicious. So I can redirect this flow to the next, for example, intrusion detection system to do further investigation. You don't have to feed all your traffic data to, for example, intrusion detection system, because if you feed all those data to your IDS system, it will be too heavy loaded. So that you can do, you can write a basic classifier to release, okay, the heavy loaded condition situation of the IDS system. So that is quite useful. Okay, so I think we can stop right here. Okay.